Good morning, everyone. It's my pleasure to introduce my colleagues and my friends, Professor Bhaskaran, Raman, and Kameshwari Chedurati. Let me get some basic bio out of the way, but that is really not what I want to focus on today. So Professor Bhaskar received his BTech in Computer Science from IIT Madras in '97, and then by 2002 he had an MS and PhD from University of California, Berkeley. After that, he was with IIT Kanpur for a few years, and then since 2007, he has been with the Computer Science Department, IIT Bombay. Professor Kameshwari got her master's and PhD from University of California at San Diego. Around 2004 is when she completed. And then IIT Kanpur again she was for a few years, and then 2007 she also joined here. You would have figured out from their bios that Professor Kameshwari and Bhaskar are not only working partners, but are among the lucky few who find a working overlap and a common cause with their life partners also. And they joined, I think, a group of lot of scientists and engineers and service people who have done this. I find that this common cause is often found in a nature of service, and I feel that this award is a small recognition for almost a lifetime of focus on really technology and not just paper chasing and publication chasing. Right from the beginning of their careers in Kanpur, they have sometimes together, sometimes different projects, but generally had a research team where they were finding problems, some very hard research problems in technology that would benefit directly people and users in the country. And very soon, and the sort of the distance from what they were doing to how useful it was shorter, even though the problem was hard enough to solve. So I will just name a few things. Work on rural net, which was sort of long distance Wi-Fi which they did in IIT Kanpur. Sensor networks for checking the soundness of a bridge, where on which railway trains can go. Then starting from that to Professor Bhaskar's work on road traffic monitoring using cheap devices, then driver safety, car safety using smartphones. Then Professor Kameshwari's work on something called Worldwide Health, which is basically knowledge on the internet to the bottom of the pyramid. So all of these are, then there is another software and methodology called Kaua Kate for detecting fake news. So this is a lot. SAFE is not a one-off thing. This is entire careers dedicated to developing technology really of use. So coming to SAFE, of course, Professor Bhaskar will tell us more about it. But again, as a user of SAFE, we have all. I have personally benefited from this app. I mean, I wasn't ever giving weekly quizzes before this app, and then because the app came, I started using that concept. We have all been able to engage our students who in class sizes which are just getting larger and larger, very hard to sort of keep track on and assess. We would definitely not do all these continuous assessments if this app was not there. So it's not only assessment, it's feedback. Many of us give SAFE quizzes as just practice quizzes, just to make sure they're listening. And so this has benefited us a lot. I just would like to mention that SAFE again is not a standalone thing. It came out of actually an entire different approach to pedagogy that Professor Kameshwari pioneered, which is flipped classroom, where the videos are released and then you are bringing, it's not that everything is online, you're bringing students to class, but you're bringing students to class to solve problems, and then you needed to have a way to ensure that students are actually reading the videos, viewing the videos, and actually studying them. So they come to class, and then you can quickly check that by this very easy app and just give a 5-minute quiz and be done with it, and that again keep some low weightage and they will do it. So this was sort of the motivation, and it's an entire package. So with that, without further ado, let me give it over to Professor Bhaskaran, who will be telling us more details about the software itself. Thank you.
And thank you for inviting for this talk. I'll keep it brief, about half an hour. Okay. So this talk I'm going to talk about some of the details of this system, SAFE, which stands for Smart Authenticated Fast Exams. The talk is on behalf of the names listed here. I hope I have not missed any. Kameswari, who has been involved along with me in the design and development since the beginning, and the various contributors, project staff, MS, MTech students over the years, over nearly 9 years now. It's in reverse chronological order. The top few lines are the current team. So I will talk about some of the technical challenges, the non-technical challenges, and our journey in the design of this system. In brief, what is SAFE? Whether you want to conduct a short quiz or a lengthy exam in a physical class or an online class. Okay. Whether you have a set of objective questions or subjective questions or a mix of the two. The set of steps for using SAFE to conduct the quiz or exam is easy, where the teacher uploads and runs the quiz or publishes. The students either scan a QR code or enter a password, attempt the questions, give their answers, and the evaluation is automatic for objective questions. Subjective questions, we have an interface for correcting, and after this evaluation the student gets the report. There were 3 motivations for SAFE when we started about 9 years back. The first was, as Professor Varsha mentioned, we were experimenting with this flipped classroom model as teachers, which was a more effective form of student engagement. The students had to watch videos before coming to the class, and the classroom session involved problem solving and higher order discussion. However, we found that the students came ill prepared. They didn't watch the videos and there was poor student participation. So we wanted to conduct weekly quizzes that counted towards the grade, so that it's serious, to improve student participation. A second thing is something we all face as teachers, where as the semester wears on, attendance falls off over time, which is demotivating for the instructor, aside from learning outcomes becoming poor for the students. So it's well known in pedagogy that regular quizzes can improve attendance. Aside from these two teacher level issues, we also conducted, many departments conduct pre-interview screening admission tests for PG admission, MTech and PhD, where we have hundreds of candidates from all over the country, and we used to spend a significant amount of time in paper pen correction. So this was the motivation. So where SAFE stands today is represented by this picture. On the left side you see a notice which is stuck outside our classrooms, which this week has become exam rooms, where it says mobile phones are not permitted inside the classroom for obvious reasons. So SAFE has successfully transformed the view of mobile phones as an opportunity for cheating in exams to mobile phones being an opportunity for conducting secure e-exams. So we stick to the spirit behind this notice while violating it in word. So the key features are that it is infrastructure free, it's cheating free, and it is robust, as I will talk about briefly. Right side is a picture of my own students in a classroom giving a quiz using their own mobile phones. Okay, so the goals for the design of SAFE as an e-exam system were fourfold. One is that we want it to be easy to set up and use for both the teacher as well as the instructors. Obviously, exam means that it has to be cheating free, otherwise the meaning of exam is not there. Third is non-obvious, but robustness is also important. If something fails in an exam, again it's a headache for everybody, for student, for I mean the meaning of an exam falls apart if there is no robustness. It has to be robust to various kinds of failures. Paper pen exam is very robust, very high, hardly any mode of failure, it's time tested. On the other hand, e-exams you can have a variety of failure modes, and that's not good. So we also wanted to scale both in terms of network as well as server. So these were the goals. What are the technical challenges in attaining these goals? First is doing all this in students' own device. Making it secure is not a trivial task, and as we will see, making it robust to different kinds of failures is also not easy. Failure should neither give more time nor less time for a student. That is what makes it challenging. And we also had an implementation challenge that at all levels exams are taken seriously by instructor as well as student. External facing exams are even more serious, and hence it was an implementation challenge to achieve usability and confidence in the system. So, how do we achieve the first goal of easy setup? The first key thing is to bring your own device. Most students have smartphones these days. Even when we started 9 years back, this was the case. So, that is the primary thing which makes it easy to use safe. Aside from that, we have a web interface which is mostly user friendly, and of course, the fact that we have auto graded objective exams makes it easy to use. What are the mechanisms to achieve cheating free operation? We have a whole host of mechanisms. I will go through some of these in detail later on, but at a high level we maintain app focus, which is track whether only safe app is being used during the exam. We of course have login based authentication and also a detailed logging mechanism and reporting to our server via a live dashboard. We log various things such as whether the user gets a phone call, the various identity related information, which access point the Wi-Fi is connected to, and so on. Robustness is handled primarily by not requiring, from day one we decided that we will not depend on network at critical times. What are the critical times? Start of exam, during exam, end of exam. During these three phases we do not need network. So, this we had to keep in mind from day one in all the design aspects. How do we achieve scaling? SAFE itself generates very little traffic. The server technology we use is a scalable state of the art one, Django Python framework. Initially, in the initial days, we spent 2-3 years figuring out how to make the network scalable. This was our initial focus when we started in 2013 until about 2015 or so. This was the focus. But later we got into this offline mode of operation where we do not require network at all at the critical times, as I mentioned, and this was a big change in terms of achieving scalability. Okay, so this is the rough set of steps which we had originally. So, what is the set of steps? Instructor uploads, that is the first one. Instructor uploads the question paper to the SAFE server, and the second step involved instructor writing on the board something called the quiz ID to start off the exam. Then the students authenticated and downloaded the exam, attempted the exam and submitted. So, those are the 5 steps. So, this was the mode in which we ran for about 2 to 3 years. So, can you see what the problem is with this model? Yeah. So, network was, so we learned this the hard way. So, in between steps 2 and 3, invariably some problem will happen. Even in a class of 30 students, 1 or 2 students will not have network, some Wi-Fi connection problem, something will happen, and this will throw off the whole thing. It will cause stress to the student, to the instructor, and it was very stressful. So, this was a problem we faced. So, we slightly changed it and brought in the current mode. So, in this, basically steps 2 and 3 are different, other steps are the same. Uploading is the same, the first step. The second step is different in that the student downloads, the SAFE app downloads an encrypted version of the exam. This makes the network requirement at the venue unnecessary. You do not need Wi-Fi, you can do with just mobile data. You do not even need that at the exam venue. The exam can be downloaded few hours before or even the day before the exam into the student's phone. And in order to start the quiz, the instructor only needs to share the decryption password, which can be done by just writing the decryption password on the board or just announcing it verbally. Steps 4 and 5 are the same, attempt the exam and submit, and consolidation of marks. So, this sequence of steps made the system robust to network disconnections. So, I will go through some of the details of the how we address the technical challenges around the challenges I have mentioned so far. So, I will categorize this into 4 questions. So, first is, how does SAFE ensure presence at the venue? How do you ensure that the student is not taking the exam from somewhere else where he or she has access to some cheat sheets or something? So, that is an important safety aspect. The second is, how does SAFE prevent copying, prevent the device from being used for copying during the exam. Robustness, I will elaborate a little bit more. And then fourth is a logistical issue which we had to handle, especially in the early years, how to handle students without a smartphone. Okay, so, the first one is the ensuring that the student is present at the venue of the exam. Something I have not mentioned so far, but some of you may know, SAFE also can be used for attendance. If you think about it, attendance is nothing but an empty exam or an exam where you ask, are you present? So, SAFE was repurposed for attendance also. So, for both quiz and attendance, you need a location check. You need the student to be present at the venue, desired venue at the desired time. So, how do we do this location? So, I will explain this using this diagram. So, before you look at the diagram, if you think about how the biometric system used to work when it was being used for attendance in our classroom, there used to be a mapping of which biometric device is in which classroom, and then there used to be a mapping of which classroom is being used for which course at what time. All of this mapping was present in a database in ASC, and that is how, when a student gives a biometric, attendance get marked. On the other hand, what we did was something much more dynamic, and it is also clever. What we do is the following: at the time of exam or marking attendance, each student's phone figures out what are the set of Wi-Fi access points in its vicinity. So, in this example, there are 4 students, S1, S2, S3, S4, and student 1, let us say, scans and detects access points, Wi-Fi access points 1, 2 and 3, that is marked by the blue line there, and student 2 detects access points 3 and 4. So, we deem that students 1 and 2 are in the same location because there is an overlap in the set of access points they are seeing. So, if they are sitting in the same classroom, this will invariably happen. This room probably has 2 or 3, I do not know, definitely 2 I can see, maybe more. Yeah, so, this overlap in set of access points seen means that they are in the same location. Likewise, student 2 and 3 are at the same location because access point 4 is common among the set of access points seen. So, and then technically what we do is take a transitive closure of this relation, same location. In graph theoretic terms, it becomes detecting the largest connected component, and this is dynamically detected as the classroom location. So, unlike the biometric case where you have to configure a lot of things, if one day a student, an instructor decides to conduct a class under a banyan tree, you can still use SAFE for marking attendance. It will detect the location dynamically. AP should be there, that you can do using a hotspot. In fact, this has happened. One of the Sitara courses used to use for a mobile course where they used to take a bus. Students used to go in a bus for different physical locations, field locations, and during that they used to use SAFE for a quiz. Okay, so obviously in this student 4, let us say, is in a hostel completely far away, is detected as being in a different location. So obviously, so one flaw in this system is that if you are just outside of the classroom, then you can get detected falsely as being in the location. This has happened. Students figured out this, and this has happened. So we have some workarounds. I will get into it if there is interest. I will mention some other mechanisms also. We are looking into this. So that is the first mechanism. So second is time check. which is especially important for attendance. So, for this, so just like we detect in the location space, access point space, the cluster of students who are at the same location, we do the same thing in time domain, where we can detect a cluster, a 5-minute cluster within the same 5-minute window of maximum number of attendance marking of the students enrolled in the course. So, this detects, so all an instructor has to do to take attendance is announce in the class, mark attendance, and the time window gets detected automatically. So, that is the second check, location check, time check. The third is identity check. For identity check, we have two levels. One is a simple device check. We simply check whether the attendance marked today is the same as the device which was used to mark attendance yesterday for that student. That is one level of check. Another slightly more sophisticated is face check. This is not quite face identification. It's not, we are not telling which student is marking attendance by looking at their face. However, we are matching the face from one selfie to another. We in fact match from one selfie to previous 3 selfies. So, this is also an optional thing, in the sense that if privacy is a concern, this can be turned off. If it is not a concern, it can be turned on. So, these are the 3 mechanisms using which SAFE ensures that a student is present at the venue during attendance or quiz. Okay, so, the second safety is how does SAFE prevent copying in quiz. There are 3 mechanisms here. One is maintaining app focus, second is network firewall, third is server dashboard. So, the first 2 are like this. What does app focus mean? When the student tries to access some other app during the quiz, a red screen will pop up saying you are not permitted during the quiz, and this event is also logged and reported to the server. By the way, this feature is possible in Android, but iOS it is not possible. Android outright blocks access to any other app, but iOS this is not possible. We simply log and report to the server. Second mechanism is firewall. This is to prevent things like WhatsApp chat and internet search and so on, device being used for such purposes during the exam. So, in our firewall we permit access only to the server and block everything else. So, this again is a feature which is possible only in Android and not in iOS. So, these 2 mechanisms are the primary ones. Dashboard I will show briefly shortly. So, robustness, I think there is no new point here. Okay, one new point with respect to attendance is that both for quiz as well as attendance, at the time of submission we mark the timestamp locally and it can be uploaded to the server at any point of time. So, for example, during attendance marking or at the time of quiz submission, if network is not there, it gets stored locally within the phone securely. It cannot be tampered with by the user later on, and at any point when the network comes up, whether it is today evening, tomorrow or even next week, it will get submitted with the correct timestamp. Okay. So, there were some things we had to be careful about in terms of even the client time can be off. It rarely happens, but it can happen by design or by error. So, those things we had to take care of while doing this. Okay. So, some of the logistics we had to handle in the early days, I will just mention briefly because this is not a problem anymore. Initially we had support only for Android, and also when we started out 8-9 years back, the percentage of students who did not have a smartphone used to be substantial, about 5%. Today it is very less, maybe only when they give it for service or something like that. But even these can be handled. So, for attendance, for example, we have a mechanism where you can use a spare device to mark, or take a friend's phone and mark using selfie, or you can also mark manually. Manual is the easiest option these days because, as I said, the number of students who do not have a smart device is very small today. Handling quiz, the 3 mechanisms we used to use. One was we had a bag full of 20-25 phones which we took to class to give to students who do not have phone. That is how we managed in the early days. Another option was when students used to be divided into batches, conduct for different batches at different times. And the third option, which also we used extensively, was just have a printed paper option for those who do not have smartphones. So, which is still being done currently for some cases, because well, you do need to handle cases where failures can happen. So, for example, if there is a PhD pre-interview screening and some student's phone runs out of battery, how do you handle it? Just give a printed paper. So, this is a laundry list of the safeguards which SAFE uses. I will just highlight some of the key things here. One is, so of course, I talked about how self-cheating is prevented. Self-cheating means using the device for cheating themselves, which is through internet search or cheat sheet. So, that is handled through app focus primarily. Collusion is handled through firewall as well as through app focus. I just want to highlight this part here, which is SAFE has no mechanism to handle over the shoulder copying or things like exchanging phones during an exam. We do not have any mechanism to detect or prevent it. So, it has to be handled by manual proctoring. So, that is why it has been designed for primarily proctored venues. Of course, it was used using video proctoring in the online semesters. Again, in serious exams, you also have to do a proper ID check against a physical ID to prevent things like impersonation. All right. So, this is in textual terms the same summary of methodology to address the challenges. I want to point out one specific thing here, which is that our dependence on various operating system level features to provide the security features. Many times we get asked the question of, is there SAFE available for Linux or Windows? The answer is no, because this is because the operating systems which are designed for mobile phones, namely Android and iOS, have a specific set of features which we depend on in order to provide the safety features during exam. These are not available in Linux or Windows. With super user access, which typically anybody with their own device have, it is very easy to subvert any protection mechanism you can design. So, we have not gone in the direction of providing SAFE, a version of SAFE for traditional desktop and laptop platforms. Okay. And the third one also I will point out here, which is not something I have mentioned so far, which is that we have followed this procedure of continuous integration. We develop feature, we roll it out. So, this is where our dual role as teacher and researcher has helped quite a bit, and also presence of other patient teachers. So, there is a constant feedback loop of development, getting feedback, fixing things which did not work, and this has gone over multiple iterations over several years in order to make SAFE what it is today. So, just for completeness, some of the features, we have the whole set of possible objective questions like numeric answer, multiple choice, multiple select, fill in the blanks, equations, images in answer, equations or images in options, and we also have a manual submission where a student writes a answer on paper and clicks a photo using the app itself and submit. So, here again in the initial years we used to face this problem of some of the phones not having a good enough camera for this scan, but this problem has gone away with time. So, various exam settings we have, usual things like duration, negative marks. Randomization is a big feature which many people like for obvious reasons. If you can randomize, then it cuts down chance of copying. Another feature which also cuts down copying is this question bank feature in combination with question category. So, you can have, let us say, a database of 100 questions under different categories. Let us say chapter 1 some questions are there, chapter 2 some other questions are there, and you can specify for a particular quiz, select random 2 questions from chapter 1, 3 questions from chapter 2 and 4 questions from chapter 3 for each student. So, this gets chosen randomly, and hence there is even less chance of copying. This is also a feature which has been extensively used over the years. Showing marks right at the end of the quiz, students like it a lot. They want to check their marks immediately. Modifying answer key and regrading these are some of the main features which we have built in over the years. So, this is our screenshot of our current live dashboard. The way it looks, the instructor gets an eagle's eye view of how many students have submitted, how many students are still attempting, at what time they submitted. We also have a log file submission status and so on, and there are also alerts. You can see here the pointer works here. Which is the pointer? Okay. Alert is here. So, alert will be things like, let us say, phone call received. Those will be popped up, of course. So, this is live with a caveat. The students who do not have network connection, it will not be shown currently, but it will be shown whenever the log comes. A quick comparison of safe versus the state of the art. There are several lockdown browsers. This is actually, lockdown browsers are more than a decade old. A computer can be configured to have only a browser which allows access to only certain websites. This is called lockdown browser. In spirit, safe is similar because it uses an app to allow access only to our server, but it is focused on smartphones. Of course, safe also addresses the issues of robustness and scale. E-exams is big business. TCS Ion is the biggest player in India. The way they conduct is using dedicated test centers at various schools and colleges which have dedicated infrastructure in terms of desktops, in terms of power backup, in terms of reliable Ethernet and so on. So, they own the infrastructure. It is an infrastructure heavy solution for conducting e-exams. This is not applicable to most of the classroom settings in which SAFE has been used. Basically, SAFE allows e-exams at a much lower infrastructure and much lower cost. You just need, if you want to conduct an exam, you just need a venue basically. Other than that, there is no infrastructure required. Students bring their own mobile, use their own mobile data and so on. There are several app based e-exam systems also, Google Classroom, Socrates, Codetantra and so on. However, our USP features of security in a bring your own device system is unique to SAFE. Robustness is also unique, and in some sense the fact that, I mean, we started about 9 years back, and this is a very busy space, especially during the online semesters. A lot of the e-exam companies have had windfalls, but despite all of this, we have withstood the test of time in terms of having unique features, which is in some sense testimony to the non-trivial nature of the technical challenges we have identified and addressed. I will just briefly mention some of the ongoing work. We are experimenting with what is known as audio based quiz password. As I mentioned, the quiz password is conveyed by writing it on the decryption password is conveyed by the instructor to the students by writing it on the board. We are exploring a process by which this can be conveyed via audio. Every phone has speaker and microphone. So, in this, the instructor simply turns on his or her phone, logs into the SAFE app, and the quiz password, the decryption password, gets conveyed via ultrasound audio. Ultrasound is not hearable to humans, which is typically above 16 kilohertz of audio frequency. So, this gets conveyed via that and picked up by the SAFE app microphones in the students' devices. This is still experimental because in some of the large classrooms it does not work reliably. Perhaps in this classroom also it will not work from this end to the other. Ultrasound fades much faster than talking frequency. Another feature which, well, almost every project these days has some AI, we also have. We are exploring what is known as keyword highlighting. So, here in the left here I am showing one of the scanned answer sheets from my question paper last year. where I have asked to draw a diagram and explain something related to some protocol feature. On the right hand side is the rubric, correction rubric. What is a rubric? It's a correction evaluation framework. I have told that if the timeline diagram is correct, you can get 1 mark, and if the explanation of acknowledgement loss and timeout is correct, you get 2 marks. So now the cognitive load of the instructor while correcting this can be significantly decreased if in this whole mass of text, students tend to write a lot, So in this whole mass of text, the keywords, so for example timeout or act, can be highlighted. So we are experimenting with this. So image processing and some deep learning algorithms can be used to pick out and highlight some of the keywords. So this is some early result from some of our experiments. So this is using a library called MMOCR along with some state of the art deep learning algorithms for keyword detection and highlighting, word detection and highlighting. As you can see, roughly it is working with reasonable accuracy, but there are quite a few errors. So we are still exploring this. This is part of the effort in the currently funded TIH lab project. So overall, SAFE has been used for objective exams, subjective exams, continuous assessment, checking mental presence. Many teachers have used, for example, in a 1.5 hour lecture, you stop after 45 minutes and ask a 5-minute quiz, SAFE quiz. This has worked significantly in improving mental presence of students. Aside from attendance is a physical presence check, SAFE quiz is a mental presence check. We also got requests for enabling what is known as classroom mode. In some colleges, perhaps for right reasons, students are not allowed to use phone in the classroom. So they have requested for what is known as classroom mode. Just like we lock the phone during the exam, classroom mode is nothing but a dummy exam in which we lock the phone and make sure the app is not used for anything else. So the phone is not used for anything else. SAFE has also been used for repurposed for surveys and polls, anonymous polls. We don't have an exact number of courses and quizzes for which it's been used, but roughly it's in those order of magnitude, hundreds of courses, thousands of quizzes, and tens of thousands of students over the last about 8 years. Other colleges have also used it aside from IITB, not so much at an institute level, but at an individual faculty level. We have conducted many workshops for teachers. Many departments in IITB continue to use SAFE for their pre-interview screening for MTech and PhD level admission. Last year, May, we conducted electrical engineering and mechanical engineering departments used SAFE for conducting their PhD pre-interview screening in a distributed mode, just like GATE is conducted in different centers. So we had 8 different centers, the 8 different GATE offices, 7 IITs and IISc. So with the help of the GATE offices, we conducted the pre-interview screening using SAFE across the country. So some formal feedback, I'll just close with this. So this is from many years back. We ran a formal feedback of how students liked SAFE. Most of them preferred SAFE. They liked the instant feedback feature. At that time, one of the not liked feature was the unfairness due to phone sizes, but this is not there anymore. So these are the 3 questions we asked during the feedback. Overall rating for SAFE, around 90% gave a positive feedback over compared to paper. Second question is, so remember we started SAFE for the periodic quizzes for each tutorial session. So we asked the question, did the tutorial quiz help them keep up to date with the course? And the overwhelming majority answered yes. And the third question we asked, it's an interesting thing, would you have attended the tutorial had there been no quiz? And 50% said no, which is also a testament of success of SAFE because it is making them attend. Okay, so this is a testimonial from my namesake, Professor Bhaskar, in Department of Mathematics, and his colleague, Professor Shivaji Ganesh. They use SAFE for one of their large BTech courses with 800 students in 2 sections, 425 each. They used SAFE for surprise quizzes, and they found it very convenient and secure to use. This is a testament from last year. SAFE was also used by KV. KV has what they call as dipstick survey. I don't know how the name comes about, but they call it dipstick survey. It's basically a survey of how well students have learned various subjects. They do this from class 1 to 12. So they wanted to use SAFE. They wanted to use a system, and they found SAFE convenient to use for this. So they select a subset of students and give them some questions and collect statistics of how well students have learned. So Mumbai region used SAFE for doing this dipstick survey, and currently there is a proposal to use the same thing across the country by KV. We have made a proposal to them. This is a picture of some students, I think 8th or 9th probably, sitting in a lab and doing this dipstick survey using SAFE. Some of the challenges and lessons learned, non-technical challenges. One main challenge has been the ever-changing environment of smartphones. Android keeps updating something, and another challenge has been the non-standard Android phones. Many of these Chinese makes, which are low cost, students is very popular among students, probably among faculty also. They don't implement Android properly. Some of the features APIs we depend on, suddenly we will find out that it's not there in some popular make of phones. So this is a constant cat and mouse chasing we have to do. That's been a problem. iOS has its own set of problems. Their entire business model is give some update and make people buy more expensive stuff. So it's an expensive proposition to do that for us. Robustness in students' staff code has been challenging. Our students and staff are very good, but they are still learning, and robustness has been an issue. And one of the challenges has been that bugs surface after several years. Probably this is common to all software systems. So for example, some race conditions like 2 TAs correcting the same quiz, different questions simultaneously, the total gets added up wrong in our code. We discovered this after many years because the correct sort of coding protection was not there. Similarly, some unhandled error, students code the correct condition properly, but error conditions they don't code. And this again gets triggered after several years because the error condition happens only when the load crosses a certain limit. And due to our own success, in some sense, the database size has been growing over the years, and the error conditions as well as inefficient algorithms kick in after so many years, and our staff and current students have to look at code which was written several years back. I mean, probably these are things which are common to all large software systems, but this is something we also faced. And some of the standard things like automated feature testing, automated performance testing, they are all there, but they are all falling into place only now. We have not had a chance to pay attention to these over the years. So I would like to end with this slide where I would like to thank several people. SAFE would not have been possible without all of the colleagues who have been very patient with bugs, including many recently. We still, I mean, continuously we keep having some bugs and some errors, which, I mean, faculty have to be patient with, and we are very thankful. The people who complained politely to help us fix those problems. Professor Kannan Moudgalya and Professor Phatak have helped in tough times of the project. Professor Anirudh Joshi and his IDC course have been instrumental in providing several rounds of user interface feedback to make it usable. Several functionaries of the institute have provided encouragement, funding to DDs, as well as Dean R&D have provided this kind of institutional support, and of course the entire institute for the environment including students, staff, inspiring colleagues with other inspiring projects. So all of the environment has contributed to SAFE being what it is today. Some of the funding sources over the years has been Imprint One funded, the MHRD funded this project, IITB itself has funded. Currently we have some funds from Technology Innovation Hub of IITB for some of the explorations we are doing.